In the diagram below, ABCD is a quadrilateral. E is a point on AD, so that AE is equal to AB, and EC is equal to CD. BEC is 90 degrees. AD is parallel to BC. Let D be 2x and B1 equal x. A, determine the value of x, and B, prove that ABCD is a parallelogram. Let's start with part A. Determine the value of x. This question gives us a lot of information, and we need to find the value of x, which is an angle. So let's look at where x lies in the diagram over here in triangle ABE. So let's make our triangle blue. We can see that AB is the same length as AE. So this is an isosceles triangle. We know that isosceles triangles have 2 equal sides and 2 equal angles. So we can say in triangle ABE, we know that AB is equal to AE because this has been given to us in the question. We also know that angle B1 is equal to angle E1, and both of these are equal to x because these angles lie opposite equal sides. Let's mark these angles in our diagram in green. And now we can make our triangle black again. Remember that a question will not give you information just for the sake of it. We can use every detail to help us find our answer. So what else do we know? The question tells us that angle D is equal to 2x, and we can see this in our diagram up here. Angle D sits in triangle CDE, so let's make it blue. We can see that this is also an isosceles triangle because EC is the same length as CD. And once again, we know that an isosceles triangle has 2 equal sides and 2 equal angles. So now we can say in triangle CDE, we know that EC is equal to CD because this has been given to us in the question. Therefore, we know that angle E3 is equal to angle D, and both of these are equal to 2x because these angles lie opposite equal sides. Let's mark angle E3 and angle D in purple. Now we can take out our blue triangle and we can make some space. These triangles have helped us find equal angles, but without the size of the third angle in each triangle, we cannot use them to solve for x. So what else do we know? The question tells us that angle BEC is 90 degrees, and we can see this up here at angle E2. Angle E2 sits at angle E along with angle E1, which we know is x, and angle E3, which we know is 2x. The question tells us that ABCD is a quadrilateral and that point E sits on side AD. AD is a side of the quadrilateral, so we know that this is a straight line, which means that this whole angle here must be equal to 180 degrees. And we can use this to solve for x. At angle E, we have E1, which is x, so we can say x, plus angle E2, which we know is 90 degrees, plus angle E3, which we know is 2x, and this is all equal to 180 degrees. And as our reason, we say because these are the angles on a straight line. Now we have an equation we can use to solve for x. we have x plus 2x, which gives us 3x. We say is equal to, let's move 90 to the right, and we get 180 degrees minus 90 degrees, which leaves us with 90 degrees. Now to get x by itself, let's divide both sides by 3, and we get x is equal to 90 degrees divided by 3, which is 30 degrees. This is the value of x. Prove that ABCD is a parallelogram. To prove a parallelogram, we need to prove that both pairs of opposite sides are equal, or both pairs of opposite sides are parallel, or both pairs of opposite angles are equal, or the diagonals bisect, or that one pair of opposite sides are equal and parallel. We know that AB is the same length as AE, but we don't have enough information to prove that AB is the same length as CD. We also don't know the length of DE or BC, so we cannot use sides to prove a parallelogram. So let's take these two reasons out of our list. We know that AD is parallel to BC, but we don't have enough information to prove that AB is parallel to CD. So we can take this reason out of our list as well. To prove that ABCD is a parallelogram, we have to prove that opposite angles are equal, or we need to prove the diagonals bisect. But this quadrilateral doesn't have any diagonals, so we can't use this either. This means that we have to prove that both pairs of opposite angles are equal. In part A, we found that x is equal to 30 degrees. We don't need to prove this again, so as our reason, we can simply say proven above. Let's put 30 degrees into our diagram at angle B1, which we know is x. We also know that angle D is 2x, so we can say angle D is equal to 2x. We know x is 30, so we say 2 multiplied by 30 degrees, which gives us 60 degrees. This is the size of angle D. So let's put 60 into our diagram. In part A, we also found that angle B1 is equal to angle E1. We don't need to prove this, so we say proven above as our reason. We know that B1 is equal to 30 degrees. E1 is equal to B1, which means that E1 is also 30 degrees. And we can put this into our diagram. We also found that angle E3 is equal to angle D. We have proven this above as well. D is 60 degrees, which means that angle E3 will be equal to 60 degrees. And we can put this into our diagram up here as well. To use opposite interior angles to prove that ABCD is a parallelogram, we need to prove the whole of angle A is equal to the whole of angle C. And we need to prove that the whole of angle B is equal to the whole of angle D. So we need to find all of the interior angles in this quadrilateral. Let's make some space, and we can look at angle A. Angle A sits up here in triangle ABE with two 30-degree angles. And we know that the sum of the interior angles of a triangle is always 180 degrees. So we can say angle A plus 30 degrees plus 30 degrees will give us a total of 180 degrees. And as our reason, we say the interior angles of a triangle. And now we have an equation we can use to solve for A. So we can say angle A, then we have 30 plus 30, which gives us 60 degrees, is equal to 180. Now to get A by itself, we say angle A is equal to, let's move 60 to the right. We get 180 degrees minus 60, which leaves us with 120 degrees. This is the size of angle A. So let's put this into our diagram. We also have two known angles in triangle CDE. So let's find the size of angle C1. This angle sits down here, and we have two 60-degree angles. So now we can say angle C1 plus 60 degrees plus another 60 degrees is equal to 180 degrees. And again, we use the reason the internal angles of a triangle. Now we have angle C1. 60 plus 60 gives us 120. So we say plus 120 degrees is equal to 180 degrees. To get angle C1 by itself, we're going to move 120 to the right. 180 minus 120 leaves us with 60 degrees. This is the size of angle C1. You can put this into our diagram. Now we still need the sizes of angle B2 and C2. So let's make some space. Both of these angles sit inside triangle BEC along with our known 90-degree angle. But without another known angle, we cannot use this triangle to find the sizes of angles B2 and C2. So what else do we know? The question tells us that AD is parallel to BC, and we can see this on our diagram over here and over here. We know that we can use parallel lines to prove angle relationships. So let's make AD and BC blue. EC touches both parallel lines. So let's make this our transversal line. Let's make it green. Now we can see that angle E3 and angle C2 sit inside the Z shape. So they are alternative angles. Now we know that angle E3 will be equal to angle C2 because these are alternative angles. AD is parallel to BC, and we know this because this has been given to us in the question. We already know that angle E3 is 60 degrees, which means that angle C2 will also be equal to 60 degrees. Let's put 60 degrees into our diagram, and we can make it black again. Now all we need to find is angle B2. B2 sits in triangle BCE along with a 90-degree angle, and C2, which we found to be 60 degrees. So we can use the interior angles of this triangle to find the size of B2. So we can say B2 plus E2, which we know is 90 degrees, plus C2, which we know is 60 degrees, will be equal to 180 degrees, because these are the interior angles of a triangle. Now we have angle B2. 90 plus 60 gives us 150. This is equal to 180 degrees. To get B2 by itself, we say B2 is equal to 180 minus 150, which leaves us with 30 degrees. This is the size of angle B2. Let's put 30 degrees into our diagram. Now we found the interior angles of ABCD. So let's see if we can prove that opposite angles are equal. Let's make some space. We know that A is 120 degrees. So let's make a note. We can say angle A is equal to 120 degrees. Angle C lies directly opposite angle A. So we can say angle C is made up of angle C1 plus angle C2. C1 and C2 are both 60 degrees. So we can say 60 degrees plus 60 degrees gives us a total of 120 degrees. Angle C and angle A are both 120 degrees. So we can make a note that angle A is equal to angle C. These opposite angles are equal, but remember that to use opposite angles as a reason that a quadrilateral is a parallelogram, we need to prove that both pairs of opposite angles are equal. So let's look at angle B and angle D. We already know that angle D is 60 degrees. So we can make a note. We can say angle D is equal to 60 degrees. Angle B is made up of B1 and B2. So we can say angle B is equal to angle B1 plus angle B2. From the diagram, we can see that both B1 and B2 are 30 degrees. So we can say 30 plus 30, which gives us a total of 60 degrees. Angle B and angle D are 60 degrees. So we can see that angle B is equal to angle D. Now we know that angle A is equal to angle C and angle B is equal to angle D. So we have now proven that ABCD is a parallelogram because both pairs of opposite angles are equal.